Hi, Randy Torgerson, High Performance. There's been a lot of controversy about these twin cam flywheel assemblies coming out of True. We have evidence to suggest that a lot of these issues are because of the support bearings to the case bearings that support these flywheel assemblies on the output shaft and on the pinion shaft. And what we want to do is show you some of the evidence that backs this up. Okay, what I'm doing here is I'm showing Ray Wheeler's crank. This crank has 90,000 miles on it. It's an S&S crank. It had been welded. It's 0 is the low point. Notice the position of the low point at the crank pin, the high point 180 from the crank pin. Also notice the pinion shaft where it rides in the bushing. It has excessive wear on the top side, i.e. on the crank pin side of the shaft. You'll notice that coming back with the dial indicator. Set the dial on a 0 at an unworn portion. Roll the saddle onto a worn portion. Spin it to the top side. It's showing 0.006 wear at the top side or at the crank pin side. Okay, now we're looking at the output side. We have the dial indicator on the output shaft, and the first thing we notice is where it's high in position to the crank pin is not 180 from the crank pin now, but 90 from the crank pin. So what we have here on this side is shift. It's not pinch as it is on the pinion shaft side. This is actually shift, and as you can see, this crank pin was welded at the 12 o'clock and 6 o'clock position on both sides. And even though this crank pin was welded, and the welds have no noticeable cracks in them, this flywheel assembly has shifted 12 thousandths on the output shaft side. Okay, now we have the flywheel assembly tore apart. The first thing we notice with the crank pin is there's been a considerable amount of flexing as the RPM and the load increases. The flywheels actually flex, as seen by these witness lines on this crank pin. We also notice the same thing in the witness lines of the pinion shaft bearing itself and the scrub mark at the bottom. Also, it's evident with the previous talked about wear on the bushing end of this shaft. The pro plugs that were pressed into the crank pin were 1/2 inch wide. The ones that we manufacture here at R&R, here at High Performance, are 2.5 times longer, so that they actually use more of a more of an area equal to the width of the flywheel. The next thing we notice, besides the flywheel assembly having the ability to flex this way, it also has done a little bit of this. The fitment of the pinion race to the pinion bearing was 2.5 thousandths, and what you will see is its ability to actually whip, which explains the wear at the pinion bushing end. We also discovered that a aluminum insert had been installed for the Timken bearing, and upon disassembly of this, the actual Timken races fell out of this insert. This insert also has signs of galling. Probably happened when this was installed. So what we did, we took the crankcase, we bored a new clean hole into it, and then we manufactured a steel insert, installed this in the case, and we have retained it with 4 flathead screws. So now when we go back together, what we will do is we will tighten up the fitment on the pinion bearing. We will run the longer pro plugs. We will also weld the crank, and we'll see what happens next. Thank you.